Okay, so we are going to start solving some of these quadratics. So again, solving is we need an equal sign. Before we start, I want you to look at this problem, a times b equals 0, and try to think right now, what are some options for a and b? So take a second. What numbers could a and b be where they'd multiply to equal 0? So try to come up with one. Maybe you came up with a is 2, and then hopefully b would have to be 0, right? Because 2 times 0 is 0. Or maybe you came up with a is 0 and b is 7. Maybe you came up with a is 0 and b is 0. So, of course, there's a ton of different options, and that's not really an interesting problem. What is interesting is when you look at the patterns between what you always notice. You always notice that either A or B has to be equal to 0. So either A is 0 or B is 0. And this is a pretty important topic as we move into quadratics, and it's called the zero product property. So basically what it says is if you have 2 or 3 things multiplying together that equals 0, then one of two things has to be true. Either A is equal to 0 or B is equal to 0. Like that has to be the case. There's no other option. One of those two things has to be equal to 0. So a couple things which you have to notice about this property I think is sort of important is one, what's in the name. It has to be equal to 0. Right? You can't do the zero product property if it's equal to 2, because there are a ton of different options, infinite options of numbers that multiply to 2. The second thing you have to notice is it has to be a product, aka we have to be working with multiplication. Cannot be adding, subtracting. Need to be working with multiplication here. So this has some really important implications, and this is kind of the reason why we factor, because we look at problems like this. And so maybe you see it or maybe you don't, but these two products are being multiplied together, right? Like if you were looking at the example above, this could be A times, and this could be B. So we have all the scenarios to use the zero product property, right? We have multiplication, and it's set equal to 0. So we know one of these two things must be true. Either x plus 3 is equal to 0, or x minus 5 equals 0. You can go through, you can solve each one. You would get x equals negative 3 and x equals 5. And you can check very quickly that this is true, right? If we plugged in negative 3 for x right here, right? Negative 3 plus 3 times negative 3 minus 5. Well, this would be 0. And this would be times by negative 8, right? And anything times 0 is going to be 0. So that, of course, works. And then it's very similar on the flip side. If we plugged in 5 for x, right, we would get 8 right here times 0, and 8 times 0 is always going to be 0. So, of course, these two solutions work, and we are getting now more than one solution. I think another important thing to see here is kind of like what this looks like graphically. What does this mean? So if you were to take out Desmos and graph this, x plus 3 times x minus 5, you would get a parabola that looks something like this. Right, so this is the left side of the equation. This is y equals x plus 3 times by x minus 5. And then we'll graph the right side of the equation, y equals 0. And that's going to be a horizontal line going through the y-axis at 0. So these intersection points, those are your solutions, right? This is your x equals -3, and this is your x equals 5. Like that's what you're solving for right here, is you're trying to find when does this equation equal 0. So these have a lot of different names. Like you'll see sometimes teachers call these the roots, or you could hear them called zeros. Is there an E at there? I don't think so. They are called roots or zeros. There's a whole different bunch of names that they, could just be the answers to the problem. It is finding where this equation is equal to 0. So this next problem, you're going to kind of see where like the beauty of factoring comes in, because now we have an addition and subtraction problem, and we can't use the zero product property, right? Like, if we want to use the zero product property, we have to have something with multiplication. So this is why we learned factoring. We can go through and factor this thing. So I'm looking at multiplies to -8, adds to 2. So I think that would be 4 and 2. One of them has to be negative. I want it to be a positive 2, so I'm going to do this one. Right? Now we can kind of see like why factoring is important. We just turned an addition problem into a multiplication problem. Right? Now we've got all the characteristics of zero product property. And we know that either x plus 4 is equal to 0, or x minus 2 is equal to 0. So you get x equals -4 and x equals 2 as your two answers. And if you were to graph this, you'd get something kind of like this. And your solutions would be right here and right here at x equals -4 and x equals 2, right? Because we're looking for when these things are equal to 0. Okay, so we're going to try one more example and then we're done. Let's look at something like this. So this doesn't look anything like what we're used to seeing. This looks totally different. And you might be kind of confused, like where do you even start with something like this? Well, right now we're pretty much just working in like the world of zero product property. So first thing you might notice is that this is not set equal to 0, right? If I want to use the zero product property, CPP, I got to set this thing equal to 0. So we'll just do that. We'll subtract 6x on both sides. And we get 2x squared minus 6x equals 0. So number one, this is good. It's now set equal to 0. Still can't use the zero product property yet, though, because I need multiplication, right? We're still working with subtraction. So I need to turn this into a multiplication problem. I need to factor this thing. So we look at this. Looks like I can just factor out a GCF. That's the quickest way to do it. I can pull out a 2x. And what would be left here? An x minus 3. Right? And so now, keep in mind, this is another form of factoring. Now we have a multiplication problem, right? Like this is my A, and this is my other product, B, right? A times B is equal to 0, right? So that means one of two things has to be true. Either 2x is equal to 0, or x minus 3 is equal to 0. So my two solutions would be x equals 0 or x equals 3. This would be a parabola, which would have to hit 0 and 3 and would look something like this. So that is it for solving. Just keep in mind these two things, right? We got to make sure we always set it equal to 0. And then, like I wrote factor here, really what I meant was it needs to be a multiplication problem, right? We need to be working with a product. So those are the two things you kind of got to check for. And that's it. Hope that helped. Thanks, guys.